For this video, we're going to review surface area and volume, but also area and perimeter. So this is two different kind of categories lumped together. Make sure you have your title at the top of the page and split your paper into 4 equal spots so that you have room for 4 examples. For example 1, it says, if a tube with a 5-inch diameter rolls down a hill in 35 revolutions, how far has it traveled? Go ahead and pause the video and copy down these directions, and when you're finished, unpause the video. Okay, the first thing I would do is note that they're giving me a shape, they're giving me information about that shape, and then asking a very specific question in relation to how many times that shape is kind of rolling down a hill. And this is a 3D shape, so I'm going to go ahead and draw it. So here's kind of a diagram of what I kind of, I'm not a very good drawer, but this is kind of what I imagine happening. So I have this cylinder and it's going to roll 35 times down this hill. And they're asking me how far is the distance from here to here if it rolls 35 revolutions. And I want to point out that the diameter right here is 5 inches. So inches, there we go. So I want you to imagine that as this cylinder is rolling, this circle is rolling all the way down with it. And if it rolls 35 times, then that would be equal to the distance from here, because this circle would be having one revolution would equal maybe this much, and another revolution would equal maybe this much. So I'm really asking, if I have this circle with a diameter of 5 inches, if it has 35 revolutions, I'm really saying, what is the perimeter of this circle 35 times? So now we know what we're looking for. We're looking for the perimeter of a circle, or as you know, the circumference of a circle. Now the circumference of a circle is 2 times pi times the radius. Okay, so the circumference of one revolution would be 2 times pi times the radius. Now the radius is half a diameter, so that would be 2.5 inches. And if I multiply this, that's going to be 5 pi inches. That means in one revolution, it happens to be 5 pi. Now, you know that pi is about 3.14, so I mean, this really is about 15 inches. But we're going to keep this in terms of pi. So now, since this is one revolution right here, let's find out what 35 revolutions would be. So 35 times 5 pi inches would be 35 revolutions. Let's see if I can fit this in here, revolutions. So what is 35 times 5? Okay, 5 times 5 is 25. 5 times 3 is 15, plus 2 is 17. That means you'd be looking at 175 pi inches, or approximately 525 inches. And both of these answers are correct. And for my approximation, all I did is take 175 and multiply it by 3. So just keep in mind, when you're looking at a multiple choice answer, either of these would be correct. Now for example 2. The minute hand of a clock is 6 inches long. What is the area of the clock that the minute hand sweeps in 30 minutes? So let's kind of make this real. So we have a clock. So here's my clock down here. I know that the minute hand is 6 inches long. So I could say from here to here, this is about 6 inches. Okay, then it says find the area of the clock that the minute hand sweeps in 30 minutes. So let's kind of imagine what that would look like. So here's my minute hand. If it's going to go 5, 10, 15, 20, 25, 30 minutes, it would travel all the way from here to here. Can you see where that would go? So when they're asking me for the area, they're really asking me for this section of the circle. So, in other words, half of this circle. So now I know what I'm looking for. So I'm going to start off with the area of a circle is pi times radius squared. And my radius was labeled as 6 inches, so this will be pi times 6 squared. So my area is 36 pi inches squared. You could approximate that by doing 36 times 3. You know, on your test it might say, okay, that's about 108 square inches. But remember, this doesn't answer the specific question. This is the total area, and they asked us only to find this area over here, or half of the area. So if I wanted to find the area of 30 minutes, that would be 36 pi cut in half, or 18 pi inches squared, or 18 times 3, which is about 54 inches squared. So this right here would be my answer of half of the area of that clock. Our next question just asks, find the area. So we're given an equilateral triangle, all of the sides equaling 12 feet. Now I know the area of a triangle is base times height divided by 2. Now I need to find the value of the base and the value of the height, and I can see that the base could be 12, but I can't find the height. Remember, the height is perpendicular to the base. Now in this case there's no height given, so what do? We draw a height. Now if you know properties of triangles, if you draw a perpendicular down, it also splits the base in half. So that means that this right here and this right here are both 6 feet now because they've been cut in half by this green altitude. And also in an equilateral triangle, all of the angles are 60 degrees. So this is 60 degrees, this angle over here is 60 degrees. And this altitude, just like it cut this line in half, it also cut this angle in half. So this whole angle is 60 degrees. That means if it's cut in half, this is 30 degrees, and this is 30 degrees. So now, okay, let's see what we've got. I know that my base is 12, and I drew in my height. It's green. Okay, so it's going to be some green value. What is this height? Now, you may have noticed the 30, 60, 90 triangle right here. So let me remind you that in a 30, 60, 90 triangle, so 30, 60, 90 triangle, the pattern of the sides looks something like this. So they're saying that this side is 6, right here. The hypotenuse is 12, which makes sense because 2 times 6 is 12. So can you find this length, or the length of the height? Yeah. It would be whatever x is, 6, and then adding the square root of 3 next to it. So now I can replace that right here. That means my height is 6 square root 3, and I can also put that in one of the values that I was looking for, 6 square root 3. So now let's do our calculations. We have everything we were looking for. The area is 12 times 6 square root 3 divided by 2. That means my area is 6 times 12, that's 72 square root 3 divided by 2. Or, if you simplify 72 and 2, that would be 36 square root 3 feet squared. Now for our last example. What is the area of a rhombus if RT is 18, so RT, this diagonal, is 18, and RS, the side length, is 11 meters. Okay, take a second to copy down our diagram in these directions, and now let's see what we've got. Okay, I know that RT, this whole length, is 18 meters. And like any parallelogram, the diagonals cut each other in half, so I can go ahead and label this as 9 meters and 9 meters. They said that RS was 11 meters, so I can put that here. But in a rhombus, all the sides are equal as it was labeled, so I can go ahead and put 11 meters all around. Now you may have noticed that they put a right angle here. That's one of the properties of a rhombus and a kite, is that the diagonals are also perpendicular. So that means that all of these are right angles. Now they asked us to find the area. And the area of a rhombus, there are 2 ways to find that. So I'm going to put those up so you can see which one you want to choose. We could use the area is the base times the height, or we could use the area is diagonal 1 times diagonal 2 cut in half. Now with what's given, I would probably prefer to go with this one over here. For this problem, they've given me the base, so 11 meters, but they haven't given me the height, and I would have to draw that in, and I don't know if I'm up for that battle. I would probably choose this one because they've given me one diagonal, And I know that I can find this piece or this piece, because they're the same, using the Pythagorean theorem. So that's going to be my choice. I'm going to use diagonal 1 times diagonal 2 divided by 2. That doesn't mean that this is impossible. You could definitely do that, but I'm going this route. I'm going to start by taking this right triangle out and redrawing it. So here's my right triangle. So it's right here. This is labeled as a right angle. This is 9 meters, this is 11 meters, and this is the side I'd like to find. So using the Pythagorean theorem, that's x squared plus 9 squared equals 11 squared, or x squared plus 81 equals 121. Now if you subtract 81 from 121, we get 40. That means that x is the square root of 40. Now the square root of 40 is 2 times 5 times 2 times 2. See if you can see how I got that. That's 10 times 4 is 40. I see one pair, so that means that x is 2 square root of 10. So that means this length that I was looking for all along is 2 square root 10, and since the diagonals bisect each other, both of those are 2 square root 10. So what does that mean? It means that SV is 2 square root 10 plus 2 square root 10, or 4 square root 10, which is one of the diagonals I was looking for. And the second diagonal they already gave me. They said it was 18 meters. So let's move this over and do some math. Now if I'm going to use this formula right here, and these are my two diagonals, then that means my area is 4 square root 10 times 18 divided by 2. Now 18 times 4 is 72. So that's 72 square root 10 cut in half. Now again, the 72 can be cut in half, so that means my area of my rhombus is 36 square root 10 meters squared. And that's the area of the rhombus.